In this case, what we saw was the value of 5 factorial was being computed by multiplying the value of 5 with the value of 4, with the value of 3, and with the value of 2, and so on, by which we are able to do it, by which the calculation of 120, which is 5 factorial, happened way towards the end of the entire computation. Now let's see an example. Let us try to complicate this simple use case a little bit more. What we'll try to do is, let us try to print instead of just the number, we'll try to print the entire string of 5 into 4 into 3 into 2 into 1 and then equal to 120. So what we want to print is something like this: 5 into 4 into 3 into 2 into 1 equal to 120. Now this might sound very simple, but what we are going to be doing to complicate this function a little bit more is, the string of label, which is 5 into 4 into 3 into 2 into 1 and equal to, is going to be computed when we go into each one of those recursive calls, and 120 is going to be calculated just like what we did right now towards the end of the recursive call, right? So you will see it once you start writing this code. This will be a really interesting way to look at how recursion works in slightly complicated areas, in complicated situations, right? Let's get into it. Now first, let us create a different function here. We'll call it def factorial with label. And here, because I would want to print both a label as well as a value, let me pass a value called label and let me pass the value of n, and let's see what needs to be done, right? In this case, it's exactly same as what we did last time. If n equal to 0, we need to check what will happen if n becomes 0. But this time we'll have a small twist. Let's try to return the entire value as a part of a list, right? With the list first element being the entire label and the second element being the value of what gets calculated. So what we'll do is, we'll return a list which actually has the label, right, and we'll append the value of plus, we'll have to append 0 because we're going to be equal to, because we're going to be towards the end of it. So when n becomes 0, we need to append equal to, because that marks the end of the entire string. And then we're going to return 1, just like how we return 1 here, we're going to return 1 here, right? Now let's make it compute what happens if it is not 0. Else, what we needed to do is, I need to create a completely new label, right? What I'll do is, I'll create a variable called new label equal to, I would want the current label appended by into, right? I need 5. If label is 5, I want it to be multiplied by 4, so I have to show 5 into, and I need to add whatever is the value that I'm going to be getting from n, which is coming to this particular value from this particular function call. So I'll convert this int into a string and call it n, right? So now what we are going to do is, we are going to pass on the one value which is less than this, just like we did factorial of n minus 1, we are going to be passing this on. But this time we wanted to return, instead of it wanting to return an integer, we wanted to return a list which contains both a label as well as the value. So what I'll do is, we'll call this data. Now data is supposed to, what it's supposed to do is, it's going to call itself factorial of, factorial with string, with label of new label, because I need to pass this information as well to it, and n minus 1, right? Now there's going to be a small difference in the way we had approached the factorial last time, because we just wanted to return an int finally from integer from this entire factorial function. But here what we also want to do is, as in when we move into the recursion, we are going to be computing the entire recursive string which is going to be printed, which is what this part is going to be. So what we have to do is we have to take care of the 120 bit as well, which means it has to calculate what happens whenever the factorial function returns. So what we need to do is we need to, just for understanding, let me just create a new variable called return value, and this return value has to be n multiplied by, now this data is going to be returning, data is going to be of type list, right? And we said that the second value, which is the index number 1, is going to contain the value. So data of 1, right? Now this is exactly similar to what we did here, where we multiplied n with the value of the integer, which is coming from the factorial computation of one number less than the value. Same thing is being done here, except that the value is returned inside a list, and inside the list we have the second value, which is going to contain the return from the function, return value from the function, so which is what we have done here. Now what we do is we return this let value. Now let's see what happens here, right? Now we'll handle one more situation where the label is empty, right? When the label is empty, what exactly happens? We'll have an extra into which is starting in the string. So what we'll do is we'll handle that as well. If label is contains nothing, then I'll say new label equal to just str of n, else new label will be whatever we just said. I think we should be done. Now let's see, we'll go to main, and instead of calling this, let me just comment this out and say print factorial with label. This time I'm going to be passing an empty string, which is nothing there, and let me just pass 5 again. So we cannot just do a print here because it's going to be returning a list for us. So what we'll do is we'll first capture this value. We'll say data is equal to factorial with label of this 5. Now what we need to do is we need to print the first one being data of 0, which contains the label, and then we need to append it with the integer value, which is contained in data of 1. We made a mistake here when we actually said when we have to return a value, it should be a list. So we need to return data of 0, which contains the value of the label that we created, and we also have to pass on the value of the computation, which is 120, which is what we need to return. Now let's see what exactly happens. Now let's open this and say python recursion.py. Yeah, now if you see, we have the output. It says 5 into 4 into 3 into 2 into 1 equal to 120. Now let's try to understand how this exactly happened, right? So let me just reduce this here, and let's again put a debugging point here. Let's say start debugging. Great. The same thing which we just did, wherein we'll be taking a look at the call stack as well as where the variables, what the value of variables are going to be in this particular section. Let's get into this particular function call. When we do that, the value of n is 5 and label is nothing, right? Now what you will be observing is the computation of 5 into 4 into 3 into 2 into 1 is not going to happen when we go into the recursive call. It's going to happen when we come out of it. But when we go inside, we are going to be computing the entire label, because that is what is going to keep track of what path we actually traversed to arrive at the final solution, right? Now initially n is not equal to 0, so it comes here. Now it sees if label is empty, yes, and so it just makes the label as 5. But here what we are doing is intentionally we are creating a new variable called new label and keeping the value of 5. We are not modifying the existing label. If you do that, then we will not be able to carry forward this entire string that we are building as and when we go into the loop to the final output. We'll be able to see why that is so in a short while. Now once we do this, we again call it back with a new value, but this time we send the new label value, which is 5, and 4 as the number. Let us see what happens. So this time when we go in, the label is already having something called 5, which is computed from the previous step, but this time we are also sending 4 for it to get computed. Again we'll go inside, and this time it is seeing that its label is not empty, so what it does is it multiplies, it puts the multiplication symbol and adds 4 to the label which is already 5. Now if it becomes, the new label now becomes 5 into 4, and we are again going to call it. This time the new label is again going to be passed, which is 5 into 4, along with the n value, which is going to be 3. We go inside, again the same thing happens, and we look at it, 5 into 4, as well as we have to add 3 to it. So far only the label is getting built, computation is not happening. At the same time you also see the call stack, which is also increasing from the main function call here to the call which has been made to this level, which is where n is equal to 3. Now again coming back here, we move, we see that again the new label is going to be appended by 3, that is 1, because this is what we are wanting to do, and then again it is going to be called along with n equal to 2. Again we do this. Now this time 2 is going to be appended to the string, which is called new label. Again we go one step down, and this time n equal to 1, this will be the last step, and again we add 1 also to the new label, and this time again we call it here, but this time we know that n equal to 0, and we need to finally append the equal to symbol to it. So what we do is, we have reached the end of the string, so we just append equal to, and we come back. Now if you noticed, look at this particular statement. It says return has given a value of string, the label is now 5 into 4 into 3 into 2 into 1, and with an equal to, which means that it marks the end. Now that we have the topmost recursive call returning, it has returned to the value of 1, but this time what we will do is, this return value which we have created as a temporary variable for storing the list that is going to be returned back from this function, we are going to be initiating this entire data of 0, which is nothing but data of 0 here is nothing but 5 into 4 into 3 into 2 into 1 with the equal to appended to it, which was built as and when we were going inside the factorial function. Right now, since we are coming out of it, which means when we say we are coming out, we are going to come out of each one of those function calls back to main. We are going to be computing the value, so we are going to return the entire string as it is, but this time we are going to multiply the value of n, which is nothing but 1, along with the data which has been returned, which is also 1. So again we come back here and we return this. So this, once we return, this time we have again the value which has been returned as 1 only, but this time the value of n is equal to 2, right? So this time the value of label is going to remain as it is, but it's going to multiply by the value of the previous call. Again it's going to return that, multiplied by 3, multiplied by 4, and finally it's going to be multiplied by 5, and finally the result is going to be returned as 120 to the main function which we originally called it. Then we are going to be printing this data in this fashion. This is what we see here. Hope this has been really useful for you in understanding how recursion works.